So today we're going to be proving this integral by using complex numbers. So first off, we know that sine of x is equal to e to the I times x minus e to the negative ix divided by 2I. We can use this definition to replace sine x. So we have in the integral of e to the ix minus e to the negative ix divided by 2I. So since we know that I is equal to negative square root of 1, we know that 1 over 2I can be factored out of this as a constant. So let's just go ahead and do that real quickly. And we're left with this integrand. So how do we integrate this? Well, we can just use integration by inspection. Recall that e to the ax plus b dx is equal to e to the ax plus b divided by the derivative of the top, which is a, plus c. So in this case, a is equal to I for this part, and for this part, a is equal to negative I. So we end up with 1 over 2I times e to the integral of e to the ix will be e to the ix divided by the derivative of ix, which is just I, negative e to the negative ix divided by the derivative of negative ix, which is again negative I. But instead, let's just write that down as positive e to the negative ix. So the i's, again, you can factor out, and I times I is negative 1. So we end up with negative 1 divided by 2 like this, times e to the ix plus e to the negative ix. Let's distribute the negative and the 2, 1 over 2. So we end up with negative e to the ix times negative e to the negative ix divided by 2. And of course, let's not forget about the plus c at the end. So this is the result of our integration of sine x using complex numbers. But how can we prove that this is actually negative cosine x? Well, let's just write down what negative cosine x is equal to. So cosine x, we know, is equal to e to the ix plus e to the negative ix divided by 2. And if we times this by a negative, we end up with negative e to the ix minus e to the negative ix divided by 2. And of course, these two are the same, with the difference of the constant, of course. Thank you for watching.